Alright, so in this problem, I have x to the power of 3 plus x equals 10. So I'm going to first start by subtracting 10 on both sides. So now I have x to the power of 3 plus x minus 10 is equal to 0. Now I'm going to rewrite negative 10 as negative 8 minus 2. And negative 8, this is the same thing as negative 2 to the power of 3 minus 2. So now I'm going to change the order real quick. I'm going to rewrite this as x to the power of 3 minus 2 to the power of 3 plus x minus 2 is equal to 0. And if I have something in the form a to the power of 3 minus b to the power of 3, this is equal to a minus b times a squared plus ab plus b squared. So in this case, this is going to change to x minus 2 times x squared plus 2x plus 2 squared, which is 4. This is equal to 0. Now, this gives me two equations. I have x minus 2 is equal to 0, and I have x squared plus 2x plus 4. And actually before that, remember how we have this plus x minus 2 is equal to 0. So now if I factor out x minus 2, I get x minus 2 times x squared plus 2x plus 4 plus 1 is equal to 0. Now I have x minus 2 is equal to 0, and I have x squared plus 2x plus 5 is equal to 0. So for x minus 2 equals 0, x is obviously equal to 2, so that's one solution. And for x squared plus 2x plus 5 equals 0, I can use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is 2, and c is 5. So I have negative 2 plus or minus the square root of 2 squared, which is 4, minus 4 times 1 times 5, all over 2 times 1. And now this is equal to negative 2 plus or minus the square root of 4 minus 20, which is negative 16 over 2, which is equal to negative 2 plus or minus the square root of 16i over 2, which is negative 2 plus or minus 4i over 2, which is negative 1 plus or minus 2i. So these are my three solutions to this problem. Alright, so in this problem, I have 9 to the power of m minus 9 to the power of n is equal to 648. So based on first glance, we can tell that m is greater than n because the result is a positive number and the bases are the same. So 9 to the power of m minus 9 to the power of n, this is a positive number, meaning 9 to the power of m is greater than 9 to the power of n, and m is greater than n. So now that we know this, we can say that m is equal to n plus some number k. And now I'm going to replace m with n plus k. So now I have 9 to the power of n plus k minus 9 to the power of n is equal to 648. Now, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 9 to the power of n plus k, that's going to equal 9 to the power of n times 9 to the power of k. Now I have this minus 9 to the power of n is equal to 648. Now, if I factor out 9 to the power of n, I get 9 to the power of n times 9 to the power of k minus 1 is equal to 648. And 648, I can rewrite as 81 times 8. So now I have 9 to the power of n times 9 to the power of k minus 1 is equal to 81 times 8. Now, 9 to the power of any number, that's going to be odd, right? 9 to the power of any number is odd. And 9 to the power of any number is odd, but an odd number minus 1 is going to be an even number. So 9 to the power of n is odd, and 9 to the power of k minus 1, that's going to be even. So 81 is odd, and 8 is even. And notice how we have something in the form a number times another number is equal to another number times another number. and it's an odd number times an even number is equal to an odd number times an even number, meaning we can set the odd numbers equal to each other and the even numbers equal to each other. So now I have 9 to the power of n is equal to 81, and I have 9 to the power of k minus 1 is equal to 8. So for 9 to the power of n equals 81, n is obviously equal to 2, because 9 to the power of 2 is equal to 81. And for 9 to the power of k minus 1 is equal to 8, this is a simple equation. I'm going to first start by adding 1 on both sides, so I have 9 to the power of k is equal to 9. And 9 to the power of what is equal to itself? 1. So k is equal to 1. Now remember how we set m equal to n plus k, meaning m is equal to n, which is 2, plus k, which is 1, so m is equal to 3. So n is equal to 2, and m is equal to 3. These are my solutions for this equation. Alright, so in this problem, I have 5 to the power of x plus 5 to the power of x is equal to 7. So to start, I'm going to factor out 5 to the power of x from my left-hand side. So now I have 5 to the power of x times 1 plus 1 is equal to 7. Now 1 plus 1, that's equal to 2, so I have 5 to the power of x times 2 is equal to 7. Now I'm going to divide both sides by 2, so then these two cancel out, and I get 5 to the power of x is equal to 7 over 2. Now from here, I'm going to take the log on both sides. So now I have log 5 to the power of x is equal to log 7 over 2. Now if I have something in the form log a to the power of b, I can move this x1 and b to the front. So it's going to equal b times log a. So in this case, I have log 5 to the power of x, and I can move x to the front. So now I have x times log 5 is equal to log 7 over 2. Now I'm going to divide both sides by log 5. These two cancel out, and I get x is equal to log 7 over 2 over log 5. Now if I have something in the form log a over b, this is equal to log a minus log of b. So in this case, I have log 7 over 2, and I can rewrite that as log 7 minus log 2, and I have this over log 5. So now that this is all simplified, all we need to do is plug in the values of log 7, log 2, and log 5. So log 7 is equal to 0.8451. Log 2 is equal to 0.3010. And log 5 is equal to 0.6990. So I have x is equal to 0.8451 minus 0.3010. And I have this over 0.6990. So if we simplify all of this, we get that x is equal to 0.7784.